The element carbon is like a treasure box. It holds various interesting mysteries. One such unique concept is that of the homologous series. What does it mean? Let's understand this in detail. Let us get to know the concept by breaking it into two parts: homologous and series. One thought we might have is that it refers to some series having similarities. Is it true? Yes, absolutely. In the first part, the word homo refers to same. So in the case of homologous series, we will have compounds that have something in common. But what is common? Here we are referring to the common functional groups. What about the next part, that is series? For being in the list of homologous series, the compounds need to occur in a sequence. That means they will occur in succession. And what do we mean by this? Let us consider the simpler alkanes like methane, ethane, propane and butane. Are they in succession? You may say yes. They occur one after the other. But what exactly makes them successive to each other? To understand this, first tell me what is the molecular formula for each. The molecular formula of methane is CH4. That's right. Ethane is C2H6 and propane is C3H8. And how is butane expressed? Its molecular formula is C4H10. Now what will happen if I add CH2 to the molecular formula of methane? It gives me C2H6, right? That is ethane. And if I add CH2 to the molecular formula of ethane, does that give me propane? Yes. Adding CH2 to the formula C2H6 gives me C3H8, which is nothing but propane. And you know the last one. Adding CH2 to propane gives us C4H10, that is butane. Now can you tell me how exactly these compounds are in series? Yes, they are in succession. And what is the common functional group among these compounds? Needless to say, it's an alkane. That means the compounds here will have the same general formula. For example, in this case, the general formula for alkanes is CnH2n plus 2. So all of these compounds show this typical general formula, right? Yes, they do. Even though they have different molecular formulae, the general formula is the same. And we also noticed a common difference between any two successive compounds. There's a common difference of CH2. Now that we've understood the concept, let's define the term homologous series in simple words. It is the series in which the compounds with the same general formula but different molecular formula occur in immediate succession. So the hydrocarbons in the homologous series will have different lengths of carbon chains, but they will possess the same functional group and will occur in succession. Now tell me one thing, if these compounds are in series with the same functional group, don't you think their properties will also be the same? Well, if you said yes, then you are apparently wrong. Because all the properties of elements in the homologous series are not exactly the same. The chemical properties are definitely similar as they are dependent on the functional group present. However, the physical properties show gradation as we go higher in the series. That's because the physical properties like the boiling point, melting point, solubility, and so on differ with the change in molecular mass. For example, a compound with 10 carbon atoms will have a higher boiling point compared to a compound with 3 carbon atoms. That's because the energy required to break the bonds will be greater. This is how compounds in the homologous series slightly differ from each other in spite of being in a sequence. This was about the concept of homologous series seen in the carbon compounds. Let's talk about another interesting concept of isomers in the next video.